Creating AI agents, particularly those based on large language models, involves a multifaceted approach that includes planning, development, training, and deployment. Here's a detailed step-by-step guide to help you understand the process. Determine what you want your AI agent to achieve. Is it designed to answer questions, generate text, assist in decision-making, or perhaps something else? The objective will guide the architecture and data you'll use. There are several types of large language model architectures to consider depending on your specific needs. Transformer models are popular for their effectiveness in understanding context in text. Examples include GPT or Generative Pre-trained Transformer BERT, which stands for Bidirectional Encoder, representations from transformers, and T5, known as Text-to-Text Transfer Transformer. Additionally, recurrent neural networks, or RNNs, are good for sequences of data but often replaced by transformers due to better performance. Lastly, convolutional neural networks, or CNNs, though primarily used for image data, can be adapted for text processing. Collect a dataset that your model will learn from. This data should be relevant to the task and as diverse and comprehensive as possible to avoid biases. Preparation involves data cleaning, which includes removing duplicates, correcting errors, and standardizing formats. Data annotation, which involves labeling the data, if necessary, for supervised learning tasks. And data augmentation, which artificially expands the data by altering existing examples to enhance model robustness. Now let's configure your computational resources like GPUs or TPUs and set up the environment for training. The key steps include model initialization, where you set up the model with random weights if training from scratch or load pre-trained weights. Next, optimization. Here you choose an optimizer and learning rate. Then there's the loss function, which defines how the model's errors will be measured. And finally, the training loop. This is where you'll iterate over your dataset, making adjustments to model weights as needed. After the initial training, evaluate the model using a separate validation dataset to measure performance. Adjust hyperparameters and retrain if needed to optimize performance. Techniques include hyperparameter tuning, where you adjust learning rates, batch size, and more. Another technique is cross-validation, which involves using different subsets of your data to train and validate. Deploy your trained model into a production environment where it can interact with users or automate tasks. Considerations include integration, which focuses on how the model interfaces with existing systems. Scaling is crucial to ensure the model can handle the expected load, and don't forget monitoring, which is essential for tracking performance and adapting as needed. Regularly update the model with new data, monitor its performance, and make adjustments to avoid drift and degradation. Let's delve into some well-known large language models and explore their practical applications across different industries. GPT-3 and GPT-4 by OpenAI are not only advanced in generating human-like text, but are also pivotal in automating customer service, enhancing content creation, and powering sophisticated chatbots across various sectors. Google's BERT has revolutionized how search engines understand queries, significantly improving search accuracy and user experience in the digital marketing and SEO industries. Roberta by Facebook, an enhanced BERT variant, excels in language understanding, boosting natural language processing tasks in areas like sentiment analysis and market research. T5 by Google, transforming all NLP problems into a text-to-text format, has been instrumental in tasks such as translation services and information summarization, facilitating communication and information accessibility. XLNet, developed by Google and CMU, merges the strengths of BERT and GPT. Its unique training approach enhances model performance in complex document processing and predictive text applications in finance and legal industries. These models are reshaping industries, driving innovation and improving efficiency. Adaptations may be required based on specific project needs or emerging technologies. Thank you for watching. Please consider subscribing and following us for more insightful content.